Here are some of the principles that we use when we're solving equations, and some examples of how to solve some of the one-step equations that we've been doing in this unit. When you think about an equation, the first thing is to avoid thinking about this as a problem, and the equal sign, and then the answer is over here. This is the way that you're used to thinking about an equal sign being problem on one side and answer on the other. But we want to start to think about that equal sign really as a balance. That there are two sides to an equation. This side is its own problem, and we're going to be doing some work with that, and the answers are going to go underneath. And this side is also its own problem, and we're going to be working down like this, and the answers are going to go underneath that. The goal of solving an equation is always to get the x by itself. We always, at the end of solving the equation, we want to have x, or the variable, all by itself. That could be 1x. Remember, that's an invisible 1 that's in front of that x there. So, but we're always, that's our goal, is always to get that, that 1x. We also want to remember that the equal sign, since it's a balance, it tells us that we have to keep this side equal to this side. So whatever we do to this side, we also want to go ahead and do to this side so that they remain in balance. So if I multiply everything over here by 2, I have to multiply this side by 2, so they're both twice as big. If I take 5 away, I have to take 5 away. Well, remember that goal of getting the equation to x. Here are some examples of expressions, kinds of things you might find on one side of an equation. And in class we practiced turning these into x. So give you a chance to kind of think about these as we go through. In fact, what you might do is you might just pause the video here, copy each of these down, and underneath it or to it, do what you would do to make that be equal to 1x. So go ahead and pause the video here, and then you can do that and come back and I'll show you what the answers are. Okay, I'm assuming you paused the video, actually did the work. This is what we would do. So here we're going to add 3 to that, thinking of that as a -3, and then those will cancel out and we'll just get x afterwards. I won't write the x underneath for these, I'll just show what it is because we don't have a lot of space, but we're just going to show what you would do. This one, there's a +7, we would want a -7 to cancel that out, and that would leave us just with x. Here there's a +8, so we're going to subtract 8 from that side. We would also subtract 8 from the other side. Here we have a -5, so we're going to add a 5 to that, combine a -5 and a +5, and we would add 5 to the other side. This is a -4, so we're going to add 4. And now looking at the multiplication and division, since this is 3x, there are two ways that I could do this. I could divide 3x by 3, that would leave 1x. I could also, if I have something like this, like 9x, and we're going to want to use that when we have a fraction involved, I could multiply this by 1/9. 9 times 1/9 is 9/9, that's 1x. If I have m over 5, I would want to multiply that by 5. That's like multiplying by 5/1. Those two will cross cancel. If I had 2m over 3, I would want to multiply that by 3/2. That would give me 6/6m. That would be 1m. I could also notice this is basically the same as that. It's going to be 2/3 times m over 1, so that would give me 2m over 3. So those are just two forms of the same quantity. I'm also going to multiply this by 3/2. 1/6, I would multiply by 6, or 6/1, and that would give me 1n. And then finally, this one, and I'll do the multiplication form of this one again, 1/4 times 4 will give me 1 whole n. Alrighty, So I'm going to go ahead and stop the video here. That gives you some of the general principles, and it gives you some practice with reducing that down to x. And then in the second part of this, I'll actually go through some examples and show you how to solve some specific problems.